3 ways to write ratios. So if you have green marbles, if I can spell correctly, green marbles, we'll say 10 green marbles, and then we'll have 12 blue marbles. So the ratio can be written in 3 ways. So we'd have 3 to 12. So it's like fraction form. We have, what did I say, 10? It's 10 to 12, excuse me, not 3 to 12. So 10 to 12, like in fraction form. And then you would have 10. And then this also means 10 to 12. So this means like the makeshift 2. And then you can write 10 to 12. So there are 3 different ways to write a ratio. Fraction form, this format, and this format. Okay, when we're talking about equivalent ratios, you're just writing things that are equivalent. So equivalent means equal to, basically. So you can use any kind of, you can multiply by anything, really. So I can say I'm going to multiply this one by 2, 5, and 11. Why can I not follow my own advice? So, I said 3 times 2 is 6. 6 times 2 is 12. 3 times 5 is 15. 6 times 5 is 30. And then we'd have 3 times 11, 33. And then you'd have 6 times 11 is 66. So, those are all 3 equivalent equivalent ratios to this one. Now, for this one here, I'm going to do the same thing. I'm going to pick some random numbers. I'm just going to do 2, 3, and 4. My pencil's not working. So, 4 times 2 is 8. 16 times 2 is 32. Okay, so now I have 4 times 3. That would be 12. 16 times 3, 48. And then same thing. 4 times 4 is 16. 2. 16 times 4. And so that would be 64. So that's equivalent fractions. We'll do this one real fast. Again, we'll do times, I can say times 10 here. So 7 times 10 is 70. Times 14 times 10 is 140. Now, I can do times 2 here. That's 14 and 28. And then I'll do times 3. So that would be 21. And then 14 times 3, 42. Okay, so all these are equivalent to this one. Okay. So this is checking to see if proportions are equal or if they're proportional, meaning they're like equal to one another. So we can multiply, and I can say 8 times 2 is 16, and then 4 times 4 is 16. So I would say yes, they are. This one is proportional to one another. And if you look here, basically 4 8s, this is just a little side comment. 4 8s, if I wanted to divide by a common factor, it would be 4. And 4 into 4 would be 1. 4 into 8 is 2. Okay? I'm sorry. Now, 1/2 would be an equivalent ratio. See, look here, 2/4 would be as well. So we'd have 4/8 divided by 2. That would be 2/4. So both of these would be an equivalent ratio. But that's kind of, we'll look at that again. 9 times 4 is 36. 3 times 12 is 36. So yes, this would be proportional. Here, 9 times 24. 9 times 24 is 216. And then we have 12 times 18. Would be 216 as well. So this would be yes. Okay. And then here we'd have 2 times 7. 40 times 7 is 280. And then we have 15 times 8. Would be 120. So no, they are not proportional. So if they don't equal, see, like these equal when you did the cross products. The proportions, you need to do cross products to check. So we have 9n 36 divided by 9. So you'd have n equals 4. So here you can check to see if your answer's right. 9 times 3, 9 times 4 is 36. 3 times 12 is 36. So this is just finding the missing product.
You help me.
Here you have 10n equals 20 times 4. That's 80. Then you have to divide. You have to divide. And so n divided by, or 80 divided by 10 is 8. So here's prime factorization. You have to get all the numbers prime. All the numbers prime. Meaning only the number and 1 can go into it. So we have 12, I'll say 12 times 3. 3. Then I have 4 and 3. Okay? Well, 3 is prime. This 3 is prime. This is not, but I know that 2 times 2 can go into that. So I know that 3 times 2 times 2 times 3 is going to equal this. So my answer is this, or 3 squared times 2. Down here, let's say 5 times 5. Now 5, only 5 and 1 can go into that. So that would be my answer, either one of those. Same thing here. We'll do 6 and 3. 3 is prime. 2 and 3. So look, I have 3 times 2 is 6. 6 times 3 is 18. All these are prime. So I have 3 squared times 2 as my answer. And then here I have 13 times 2. 2 is prime. 13 is prime, because only 13 and 1. So this is my answer. Okay. Now, LCM. LCM is just you're trying to find the multiple that they have in common. So here I have 24, 48, hold on, I'm having to do the math. 72. And then we have 96. Okay. So here I would have 48, 96. Then we have 144. $192. So we have to figure out what they have in common. So the lowest common multiple that they have in common is actually 48. So the LCM of 24 and 48 is actually 48. No, same here. 15, 30, 45, 60. Okay. 75 and 90. So we have 45, 90, 135. So if you look, we can already see that they have 45 in common. That's the lowest one that they have in common. So that's the LCM. Same with this. I can do 5, 10, 15, 20, 25, 30. Here I could go on 30, 60, 90, 120. Well, the lowest one would be what? 30. So the LCM would be 30. Now, there's another way we can do this. Okay, I'm not going to do this one. So, I could do the LCM of 63 and 21, and the same way as up here, just doubling it. You know, well, not doubling it. 63, 126, and so on. 21, 42, 63, and so on. However, I can do it this way. I can say, okay, 21 times 3 is going to be 63. Okay, we have to make them all primed. And then I have 7 and 3. And then I have 7 times 3. Okay, so then I'm going to put these in order. So all these, I'm going to have 7, 3, and 3. And then I have 7 and 3. So I'd have to bring down what they have in common. So they have 7, and they have a 3 in common. So the LCM would be 63, using prime factorization. So for LCM, you can do two different ways. You can do just listen the multiples, or you can use the prime factorization. So either one of them would work.